All right, in this video, I'm going to be working just a few more interval of convergence problems that are very similar to some pretty common College Board items. They're just going to kind of talk about the interval of convergence and what can you conclude about some other value of x. Okay, so we're talking about a power series, some kind of series that involves an x, or maybe an x minus a number. So what we say is that this is a power series centered at x equals c. And, okay, I told you about the power series, and we'll see more about the centering thing when we go to study Taylor series. But I think what I told y'all in, when we were talking about ratio and interval of, or radius and interval of convergence, using the ratio test, was that this series will always converge at x equals c. And it converges kind of trivially because you're just adding together a bunch of zeros. We're adding on n, in case that wasn't clear. You're just going to add a bunch of zeros together, so it always converges at c. But there's going to be often times where it converges at other values besides c. We've seen this. We've run the ratio test to find the interval of convergence. You'll have some experience with that. And we know that it goes out some number of units in each direction. And we call that the radius of convergence. And then there's, some endpoint of the interval of convergence. And we remember when we do the ratio test, this is where the limit is equal to 1. So we have to check, because the ratio test is inconclusive when the limit's 1. And it might come back both converging, both diverging, one converging and the other diverging, something like that. And what I'm going to tell you is that in the interior of this interval, this is where that limit is less than 1, right? And the ratio test tells us that if the limit is less than 1, the series converges absolutely. Okay, so okay, so I'm right. In the interior of the interval of convergence, the series converges absolutely. Okay, that's a fact. Now we have seen occasionally, where, maybe it was, on this right endpoint we checked it and it converged, but it was the alternating harmonic, and it could converge conditionally. But outside of that, we conclude that it diverges. Okay. And I've kind of run out of colors here, so I guess I'll use maybe brown. And it diverges out there. Okay, but what y'all need to know for these questions I've got is that if a power series converges conditionally, the place where it converges conditionally is the endpoint of the interval of convergence. Okay? It's not the case that every endpoint that converges will converge conditionally. I believe you can just look at the multiple choice and see, I think there's one where that happens, where both endpoints converge and neither converge conditionally, because it was a 1 over n squared type thing. But if a power series converges conditionally at a value, that's the endpoint of the interval of convergence. Okay? All right, for example, they could tell you something like, hey, this series converges conditionally at x equals 7. What can you say about the series at x equals 5, x equals 8, x equals 0, and x equals -1? Okay, well, in a multiple choice setting, which is, I feel like, where this is much more likely to appear, what can you say about the series? It's always phrased as, which of the following must be true? Okay, and so they would say, for each of these values I've listed, it converges or diverges, and all of them would be untrue except for one. So I'm going to go over here, and I'm going to draw myself a little number line. I know that this is centered at x equals 3, and that it converges conditionally at x equals 7. What I know is that if it converges conditionally at x equals 7, 7 is an endpoint. Meaning that the radius of convergence is 4. So I need to be able to go 4 in the other direction, and I'll have the other endpoint of my interval of convergence. So 3 minus 4 is negative 1. Okay. On the interior of the interval, I know this thing's converging absolutely. I'm going to use the same color scheme. And I know outside of that interval, my series is divergent. Okay, so if it asks you, what can you say at x equals 5? What would y'all say about the series at x equals 5? Converges absolutely, yes. Okay, what could I say about the series at x equals 8? Diverges, for sure, because it's outside of the interval of convergence. Okay, x equals 8 diverges.
So does -1 also converge conditionally, or just...
Okay, yeah, I'll talk about -1 here in a second. That's definitely on my list. Actually, let's just jump to it right now. X equals -1. Any thoughts on -1? You feel like it does. It's possible that it does, that they both converge conditionally, or that it even converges absolutely at x equals -1. But it's also possible that it diverges at -1. It could be that, this is a really simple series, like, I hope this goes well because I'm recording, but sum of x minus 3 to the n over, I think it would need to be 4 to the n and n, or something. This might not work. Okay, so if I plug in 7, okay, I guess I would just need a negative there, or something. -1 to the n. Negative to the n. That's what I had room for. Okay, this one, at x equals 7, converges conditionally because it's the alternating harmonic, whereas at -1, I've got the regular harmonic and it diverges. Okay, so I could cook up one where it diverges. And oftentimes it is alternating harmonic on one end, harmonic on the other. And there would be a lot of ratio test work in there and analysis to determine. But at x equals 1, we don't really know. Possibly converges, possibly diverges. And then, okay, the other one I'd asked was what happens at x equals 0, but that's on the interior of the interval. Maybe I'll just talk about x equals 3 again. What's happening at x equals 3? It's converging. And what is it converging to? Yeah, it's converging to 0 because I'm just adding up a bunch of zeros. So that's something interesting I can say. And, if they asked the radius of convergence, that's equal to 4. That's one solid example of the type of question they can ask. Okay, this one is an older type of question from before they started asking about absolute and conditional convergence. They just said, they basically told you in code that it's centered at -2, and that at -6, it converges. Now, this is a pretty tricky question, because that means that we know that the radius of convergence is at least 4, but not necessarily 4, because they didn't say it converges at x equals -6, but does not converge for anything more negative than -6. So what I'll say is that the radius is at least 4. Okay, so -2 plus 4 would be +2. Okay, so they could ask you questions about, let's see what I said, x equals 0, x equals -1, x equals -7, and x equals +2. Okay, so at x equals 0, what can we conclude? Yeah, it converges absolutely because I know the radius is at least 4, so I know that in where I'm coloring in red, it's got to converge. Okay, at x equals -1, same thing. I'm not sure why I'd ask that question as well. Same. Okay, just gonna remove that. What about -7?
Don't know.
Yeah, you don't really know. It could converge, but it could also diverge. Okay, can't say. And then at x equals 2, Same thing. It maybe convergence. Yeah, because if we knew that it converged absolutely at x equals -6, we still couldn't say anything because maybe it converges conditionally. That's the end point. Maybe it diverges. Yeah, we don't know. Okay. So this one you really can't say as much, but you can say that the radius is at least 4. Okay. So this is a very specific type of question, and there must be a reason with the test coming up that I made this video for y'all with practice problems, but it's kind of different from how we've asked these questions. You'll see it at the bottom of quiz 11.4, question like that, and then you'll see it again in the next unit. So I just wanted to kind of make y'all aware of that problem before you needed it. And that's all I got for you.